We are going to look at similar triangles, and we thank you for watching all our videos. Mr. Academia, I will remind you to subscribe. Press this button here to subscribe to our YouTube channel and such that you enjoy all our lessons. Like our lessons, share, and also comment on our lessons. So we are going to continue with similar triangles as our today's topic. Uh, uh, if you look at the proportionality theorem of triangles, if a line is parallel to a side of a triangle, as you can see in this diagram here, we have a line which is parallel, like this line here. It is parallel to this side of the triangle. This one, this line is parallel to this. So the line PC is parallel to the side SE of a triangle, as you can see. It intersects the two sides of the triangle, and therefore it divides those sides proportionally. As you can see that it intersects the side AS, and then also the side AE is also intersected. So meaning that these sides are divided proportionally. This side AS is divided proportionally into AP and PS, and also this side is divided proportionally into SC and CE. So that implies that the ratio, since these sides are divided proportionally, the ratio AP to PS is equivalent to the ratio in which the other side is divided, that is AC to CE. That is according to the proportionality theorem of triangles when they are divided by a line parallel to one side of the triangle. So, but also you should take into consideration that the ratio of AP to PS is not equal to the ratio of PC to SE. So this one here is not true, but is only true for these two sides which are divided proportionally. If you look at also still looking at the same theorem, which is the proportionality theorem, if a line divides two sides of a triangle proportionally, then it is parallel to the third side. Of course, this is true. You can see PC is parallel to SE. These two are parallel to each other, and still the same notion holds. That is AP divided by PS is always equal to SC divided by CE. So if this happens, then that is what we call proportionality of triangles, or proportionality law of triangles. So still it can also happen that we have two transversal proportionality. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. As you can see here, we have this line here, there is this line, there is also this one, there is this one. So these three lines are parallel to each other. So it means that this distance from here to here divided by the distance from here to here, that is CA divided by AT, this one here. It should also be equal to this one divided by this, also divided this one here divided by OG, which is DO divided by OG. So this one is also true when you have three or more parallel lines, as you can see in this diagram here. So we shall use those properties of those proportionality properties to determine or to solve some of the questions that we have here. So as you can see here, if you're asked to find the distance x here, so we are going to use that property. Since these two lines are parallel, it means that they divide the side proportionally. So that means that the side OC divided by CS, this should be equal to the ratio of the side OP divided by PE. So this implies that 10 out of 4 should be equivalent to 14 out of x. So you go ahead and calculate the value of x by cross multiplying, which gives us this one here. And then we end up having x as being equivalent to 5.6, but we are using the law, the proportionality law for triangles. When the line divides, when when a parallel line divides the triangle proportionally, or divides two sides of a triangle proportionally. If you look at another example, in this case here, we have this line HE or EH is parallel to the line SO, or call it OS. So these two are parallel. So it means that the sides HR and the sides ER are divided proportionally. So this means that HO divided by OR is proportional, is divided in the same ratio to the side ES to SR, as you can see. So if we go ahead and substitute in the values, we shall end up having 15 out of 10. This should be equivalent to ES, which is 12 out of 8. But remember, they want us to verify, so we should make sure that we get, if this ratio is similar to this ratio, then the two lines, the two lines HE and OS are said to be parallel. So if we work out this side, we shall end up getting 1.5. And then if we work out the other side, that is 12 divided by 8. I think it's also 1.5. So since the two give the same ratio, then it implies that the line HE, this line HE is parallel to the line OS, since they give the same ratio. Or if you want, you can do it in this same way here. They've done it here. But still, you have to show that the ratios in which the parallel line divides the sides is the same. If you look at another question here, here we are having 3 parallel lines, so we are also supposed to use the same notion to solve this. So meaning that 10 out of 6 should be equal to x divided by 9, as you can see here. Then you go ahead and solve for x, and x will be 15, as you can see here. So basically, we are still using the triangle properties to solve this. If you look at the triangle angle bisector theorem, it is also a theorem which helps us to deal with similar triangle issues. So according to this, an angle bisector of an angle of a triangle divides the opposite sides into two segments that are proportional to each other. So for example, this is an angle bisector AD. AD is an angle bisector. It divides this angle of this triangle. And then since this triangle shares this angle and this one, these angles are shared, then the sides or the opposite sides are divided into two segments which are proportional to each other. So that means that if you consider, for example, there is this side here, there is this side which is ACD, and then there is the other side which is ABD, or call it ADB. So this implies that the side CD divided by CD divided by CA should be equal to the other side is DB divided by AB. Or you can also write it in this same way that has been written up here. It still carries the same sense of the notion that we are talking about, or of the theorem that we are talking about. So if you look at an example here, we are supposed to look for x here, but remember this is divided by this angle. This angle is divided by the line BD. So that implies that AD out of AB should be equivalent to DC out of BC. If we go ahead and substitute into this, we shall have AD, which is 3.5 divided by AB. AB, which is 5, this should be equivalent to DC, which is x divided by BC, which is 12. So if you work out for x, you'll end up having x being equivalent to 12 multiplied by 3.5 divided by 5, and the answer for x is 8.4. The answer for x. So if you want, you can also do it in this same way here. It is the same. The answer is similar. It is also 3.8. Okay. If you look at the indirect measurement, so indirect measurement here, we are not basically the angles. We may not have a parallel line that is dividing the angle, but if you look at indirect measurements, we are comparing two triangles which have angles that are similar, at least two angles that are similar. For example, this angle here is similar to this, and also this angle here is similar to this, and these angles occupy same positions in the two triangles. So the sides of these angles here are also said to be similar, or these triangles are said to be similar triangles because they share similar angles in the same positions. So in this case, the ratio of this side to this one should be similar to the ratio of this side to this one for the two triangles. So for example, if I have these two triangles, it means that the ratio of 8 out of x, this ratio should be equal to the ratio of 6 out of 18. Those two should be the same. So this means that if we cross multiply, we shall have 6x equals to 8 multiplied by 18. And if you work out this, you end up with x being equivalent to 24 feet. So if you want, you can compare the ratio of the sides of this triangle to this one, or you can compare sides which are matching like I've done here, but still it all ends up giving you the same answer for this question. There is another question here. Miriam saw a mirror on the ground and noticed that she could see the top of the reunion tower in the mirror. Her line sight was 5 above the ground and the mirror was 2 degrees away from her. She measured the distance, as you can see. So this is the question here. So if we look at the solution to this, of course, we are going to use the same notion because this angle here, I'm sure this angle is similar to this, and also this is 90 and this is also 90. So that means that the ratio of this side to this one should be equal to the ratio of this side to this one here. So that implies that if you get 5 divided by x, this should be equal to 2 divided by 224. So that means that x will be equivalent to 5 multiplied by 224 divided by 2. And you finally have x as being equivalent to 560 feet. So if you want, you can still use this same notion here to find out what is being required in this question. Okay. We thank you for watching, for sharing our lessons. Remember to comment and also subscribe to enjoy the best out of our lessons. Thank you very much.